So these videos
Good
are
evening all.
recording or?
Yeah, recording is going on. So good evening all. So welcome you all to the fifth webinar. So as most of the people know that we started 2 months before and we already conducted four webinars successfully. And today is our fifth webinar is related to selection of HVAC equipment and we mainly targeting chiller here. So chiller we have covered lots of technical topics today, the lots of technical terms today. So it will be a very interesting webinar today. So as most of the people know that because you people have joined the previous webinars, what is the main vision mission of the TIECONN? So TIECONN Technical Innovation and Engineering Collaborative Network. So it's a recently started group. It's a very fast growing group also. So we are conducting webinars and mainly we are conducting 3-4 webinars in a month covering the all the technical topics related to MEP. And very soon we are going to start the workshop also. For example, very soon we are planning to conduct a full day workshop related to HAP calculation and HVAC firefighting hydraulic calculation and many more technical topics related to HVAC firefighting and plumbing. And we have the active WhatsApp group. So in the WhatsApp group, you can see the job details related to Middle East and India and Asia countries we are sharing there. And also, if you have any technical doubts, also you can ask in our WhatsApp group. So we people are there to answer at any times. So this is the main mission and vision of TIECONN. And coming to our team, so these are the three committee team who started this active group, and we have a very executive leadership team from different vice president, woman chair, membership chair, and program chair. Also, we have the head of country chairs who take charge of all the countries chairs, and we have the secretary from Pakistan. We have the vice secretary from India, Balaji, and we have different country chairs from Bahrain, Pakistan, Qatar, Saudi, and UAE. So additionally, we have the vice chair also from different countries who are the main pillar of our groups. And we have the technical advisory team. So we have planned for a very long-term growth, and we have some long-term mission also. So these are the people working towards the success of the TIECONN. And we have a very active youth and student division also. And the main pillar of the TIECONN, we have the events team who are actively coordinating with the different industry experts to arrange different webinars and technical events. So these are our media and communication team. And coming to our today webinar, selection of AC equipment chillers. So we have our active member today. That's Mr. Raghavan, senior sales engineer. So he has prepared a very good presentation for you to do, you to see. So I give my mic to Mr. Raghavan. Yes, Raghavan, you can start the presentation now.
Yeah, thank you, Mr. Nagaraj, and it's always pleasure to meet everyone in the team, and especially a big thanks to TIECONN team for giving me this opportunity to share the insights about this particular topic about regarding the air conditioning equipment selections. The right selection is not only ensures the occupant comfort, and also it also impacts about the energy efficiency, operational reliability, and long-term sustainability. So in this presentations, I will walk you through the key parameters that must thoroughly be evaluated before approving any selections as a air conditioning engineer. So I will, in my presentations, you will have more data which can be correlated, and it will be easily understandable. So I would like to have an interactive sessions so that everyone can understand. And when you always talk about, you will always able to understand, and when you discuss more, you will be able to understand more. So let me share my screen and start the presentation. Nagaraj, can you please confirm whether the screen is visible or not?
Yeah, now it is visible. You can start. Yes.
Okay, let me go through the agenda for today. So the agenda for today, already the introduction is completed. So the following topics will be covered today. Why it is important to give a focus on selection of equipments, and classification of air conditioning system. What are the key parameters required for selection of equipments, and evaluating a different selection of equipments. evaluating the chiller efficiency and understanding IPLB. And this is an important topic, which is decarbonization and net zero energy buildings, because this is going to be the future decarbonization and net zero energy buildings. I will just slightly touch upon this, how it is going to relate with the selection of equipments, and then final summary will do, and then we'll have a short quiz, and then we'll have some certificates also given during the presentations. So now going back to, yeah. So when you take any buildings, okay, you will have the lighting load, you will have HVAC load, and you will have a chiller plant load. So when you take a complete building, the 50% of the power consumption will be from an air conditioning plant, and in that the chillers is going to be the energy guzzlers. The chiller will consume a lot of power compared to any other HVAC equipments. So when you have a right selection and energy efficient chillers, the operational cost will be coming down. So let's see how it is. So let us take a real scenario, understanding the impact of energy efficiency. So let's have a building of 500 ton, and let's say you are operating 250 TR, 2 numbers of air-cooled chillers. Assuming your first cost of air-cooled chiller is for 2 numbers is $220,000, and let's see how much is the operating cost per year this will be incurring. So what I have done is 2 chillers operating at 250 ton, 0.85 kilowatt per ton, which will give you the kilowatt hours. So let's say operating 16 hours a day and 300 days. So this will be consuming 2 million kilowatt hours. This is how the chiller power consumption will be calculated. So this 0.85, how I have calculated is based on the annual energy efficiency kilowatt per ton. So this will go in detail in the upcoming slides. So right now I am just assuming how why it is important to have an energy efficient chillers. Let us see how much is the operating cost for this operating 250 TR chillers. So as per let's take Dubai government tariff fares, like we have AED per kilowatt hour, which is 0.38. So I'm just assuming like $0.1 per kilowatt hours. So the operating cost is $204,000. So which is almost equivalent to the first cost of the chiller. This is only for 1 year I'm talking about. So what we have to understand basically is the chiller initial cost is almost same as the operating cost of a in a year of a chiller. So 220,000 versus 204,000. So when you consider for a lifetime of a chiller, like it operates at 15 years to 20 years, so we should be thinking which will be like 20 times more, 20 times higher than the chiller cost. So when you invest on an efficient chiller, your operating cost also will come down. And then when you maintain it better, yes, definitely the operating cost will come down, which will save the customers. So this is why the energy efficiency is much important in the upcoming scenarios, in the upcoming buildings, and in the future. Okay, let us touch about some of the basics about air conditioning, then we will move to the chillers. So what is air conditioning, which means removing of heat from one location to another location. Let us take a room. You have human load, you will have lightings, you will have infiltrations, you will have the equipment load, and you will have the infiltration from the neighbor, from the below buildings. So how the air conditioning basically works, you will have sensible load and the total sensible load and the latent load, which has to be addressed and it has to be removed. So how do you remove it? You will have to send the air which is a dehumidified air and which is at a much lower temperatures. So the process of removing heat from one location to other, in this case you are removing the heat from inside the building to atmosphere, to outside. So if you see the pressure enthalpy chart, this is the chart which talks about you have to absorb, the refrigerant absorbs the heat from the load. So to remove the load, we can use two mediums, either the refrigerant or through any other medium like chilled water type or basically the most of the domestic purpose they use the refrigerants, and most of the commercial projects they use water as a medium to remove the heat. So in this case, for a small room, you might have used split air conditioners, which will absorb the heat from the room and remove to the atmosphere. So this is how the air conditioning basic process it works. And based on the heat transfer media, we have two types. One is the direct expansion type and indirect expansion type. So what is direct expansion type? The refrigerant will be the medium, as I said before, will be useful for removing the heat from one location to the other. And water system, as I told you, it is called as indirect expansion method, which is the water system. And the common will be the air system, your air handling and FAHUs, which will be common for both the systems, which will be useful for transferring the heat. So what are the technologies available with us currently? The room air conditioners, which comes under the direct expansion, VRF and VRV, we call it comes under still a direct expansion type. And chillers, which comes under indirect expansion type, we will be cooling chilled water remotely, and then using a pump you will be sending the chilled water to the buildings. So that is how the chilled water works. So we will touch upon the basic components and the cycle of the refrigeration. So 4 components we have basically for the refrigerants. One is the compressor, condenser, expansion valve, and the evaporator. So I will not go into detail about this particular slide because it is already it's a basic one. So I'm just going to the next one. So we will go in detail about the type of components like compressors, condensers, and evaporator. What are the types? And then we will go further. So compressor types, we have reciprocating. These reciprocating compressors are not widely used in the industry. And let's talk about the scroll compressors. Scroll compressors, the starting capacity like 20 TR, or even some of the manufacturers have very low, like starting from 2 TR to 150 TR maximum with the scroll compressors. Usually it will be like a DX type system, evaporator system most likely. And these are used for few of the domestic purpose and a few of the domestic purpose and mid-size industrial purpose. This will be used, these compressors. And for screw compressors, 100 to 450 ton, or some manufacturers have still 600 tons as well available as a compressor, which comes with the multiple compressors. And this is mostly used in industrial and commercial applications. So what is there above 450 ton? We have a centrifugal compressors, which ranges from 300 to 3,000 tons. So whenever your capacity is more than like 1,000 tons or like 6,000 tons, 7,000 tons, mostly this will be in a district cooling plant or in the infrastructure like airports, bigger projects. You will have these kind of centrifugal chillers which will be there. Yeah, Nagraj, any doubts? Okay,
No,
I'll move on.
we will discuss later after your.
Okay.
Yeah, someone raised the question. Yeah, we will discuss later.
Okay, fine. So next move to, we have seen about the compressors. Now let's see, talk about the heat exchangers, which plays a important role. So condenser type in an air-cooled chiller and a water-cooled chiller, I will explain to you. So the condenser type, you have microchannel heat exchangers and copper and aluminum fins. So the left-hand side, which you have seen, is the microchannel heat exchangers, and the right-hand side is copper tubes with aluminum fins. So earlier generations, they were most likely using the heat exchangers with copper tubes and aluminum fins, but later now there is a shift in using microchannel with microchannel heat exchangers. So this microchannel heat exchangers, why this is used compared to copper and aluminum is like basically it has a higher heat exchange area and it has very low pressure drops, air pressure drops, and this has higher efficiency compared to copper and aluminum. And another advantage it has is it consumes lower refrigerant per ton compared to the copper and aluminum. And this is basically the lightweight, because considering the density of aluminum versus copper and aluminum, this fins, the density of microchannel heat exchanger is always less. So the weight of the complete chiller will be much lesser. And one more good part is the galvanic corrosions will not be there, because it's a symmetric metal, unlike copper tube and aluminum fins. You have dissimilar metals of copper and aluminum, where over a period of time you will have a galvanic corrosions. So microchannel heat exchangers will be the winner in all these cases. One disadvantage with microchannel heat exchanger is if there is any leak, it is very difficult to arrest. There are some solutions which is coming in the current scenario which will be able to address this. So most of the manufacturers have shifted to microchannel heat exchangers, considering its efficiency and lesser weight. Considering this, all the manufacturers have been shifted to, but still the copper aluminum is still being used wherever you have a high corrosive environment, or sometimes copper fins also being used in some of the very harsh environments. Copper is also being used. So this is all about the condensers which is being used in an air-cooled chiller, microchannel heat exchangers on copper aluminum. And let's move to the evaporator part. So evaporator, we have like a smaller capacities, we have brace plate heat exchangers, which is up to 150 tons. And we have a shell and tube heat exchangers as well, which is we have different types of shell and tube heat exchangers. One is the DX type and flooded type, falling film and hybrid falling film. So basically how it looks like. So brace plate heat exchangers, you will have 4 holes where the chilled water will be going in one side, and then the fluid to be cooled will be going in the other side. What happens? Only the heat transfer takes place. So up to 150 ton, this brace plate heat exchanger is being used, considering the compactness of the chillers. So this is a flooded design where, okay, the difference between the DX type and the flooded type, the DX type, the refrigerant will be on the tubes and water will be on the shells, and flooded type, the opposite. The refrigerant will be in the shell and water will be in the tubes. So this is a flooded design where you can see the refrigerant is the blue color one, which is the refrigerant, and the white color is the water, which will be passing inside. So the heat transfer will take place. So falling film is an advanced. Yeah.
Heat exchanger slide is not visible, sir.
Okay, Nagaraj, you are able to see this slides?
Yeah, we can see. Yeah. Yeah, it's visible. Yeah.
Okay, fine. So falling film or hybrid falling film is an advanced technology where the refrigerant will be sprayed on the copper tubes, which will have this also is a advanced technology where some of the manufacturers are being used, where this requires a very less charge of refrigerant compared to the flooded design. Flooded design is like a bathtub where you completely immerse yourself. This is like taking a bath in a shower where the refrigerant will be sprayed on the copper tubes. So that you can assume like in a bathtub you require more of water, and here in a shower you require very less amount of water. So just correlating things so you understand better. So the charge of refrigerant is much lesser in a falling film or hybrid falling film technology compared to the flooded design. So let me move to the next one. Okay, so when we talk about an air-cooled chiller system, okay, this is how the air-cooled chiller looks like. You have the condensers, you will have the condenser fans, and you have the evaporator, and you will have a pump actually to circulate the chilled water to the buildings. So when you talk about an air-cooled chillers, this is a simpler design, rejecting the heat to atmosphere. When it is rejecting the heat to atmosphere, that's why it's called as an air-cooled chiller. Mostly it will be working on a dry bulb temperature basis. And this is compact, suitable for outdoor and rooftop installations. And initial cost for overall system is less. That is only when you take only the complete system, including chillers, pumps, the initial cost will be the less. The life expectancy will be 10 to 15 years for an air-cooled chiller. So this is the basic of air-cooled chiller, how it works. When you take about a water-cooled chiller system, this will be rejecting the heat to cooling tower. Always the water-cooled chiller will work on wet bulb basis, where you will have a separate loop for evaporator, which is going towards the building. The other loop which goes to the cooling tower to reject the heat actually. So This requires a larger footprint area where you will have a cooling towers, you will have a condenser water pumps, and you will have water treatment plant to keep the cooling tower water to be maintained at a certain pH levels, because there are some recommendations will be given from the manufacturers to maintain the water quality parameters, which has to be maintained by the cooling tower, because basically these cooling towers are open type cooling towers. You will tend to have more types of impurities, and due to the heat transfer, you will have the chances of forming the scale if your water quality is not proper. So the maintenance for the water cooled water treatment descaling on the condenser is more compared to an air cooled chiller. So in the air cooled chiller, you will completely eliminate the cooling towers. The life expectancy of the water cooled chiller is higher. It's almost like 20 years. And the best part in a water cooled chiller is it is very efficient compared to an air cooled system. Because say let's assume like during in the Middle East conditions, air cooled chiller is consuming 1.5 kilowatt per ton. The water cooled chiller consumes like 0.7 or 0.8 kilowatt per ton. So this is much efficient system, water cooled chillers. So wherever you have a water availability, we can always go for an water cooled chiller system. Wherever you have scarcity of water, or when you don't have a space, then the choice we can make either water cooled chiller or an air cooled chiller. So what is the operating parameters required for a water cooled chiller? We have the AHRI conditions defined, Euro 1 conditions, and the sample specifications. So a water cooled chiller, as I told you before, the chilled water inlet and outlet 54-44, which is 12.2 and 6.6, and fouling factor, and this is the condenser water loop 85 and 95. This is based on the AHRI conditions. And this is an example of 300.
I have one question.
Yeah, please.
I have one question.
Yes, please.
And difference between the temperature. For example, I am designing the one project, okay? Chiller. So how will decide the delta T, T2 and T1? How will it select any? Which base I will select?
I have the next slide coming up regarding the delta T and water flow rate. I will answer your question. Your good name, please.
My name is Delta.
Okay, I will cover in the next topic. The water flow rate and delta T, I will cover in the next slides. Okay. Yeah. So 54 and 40, yeah,
okay, fine,
54, 44 and 54. This is the evaporator loop and this is the condenser loop. Okay, fine. So you will be seeing the fouling factor 0.0001 0.0025. So what is the fouling factor? Okay, the fouling factor is nothing but the resistance to heat transfer. So you will see the manufacturer data like 0.0001, 0.00025, 0.00005. What is the meaning of this? Is one thing is resistance to heat transfer, and over a period of time, when you buy a chiller, this chiller will be performing much better than the performance declared from the manufacturer, because the copper tubes will be much clean. You don't have any scale formation on the copper tubes. This will be Nagaraj, can you mute the participants if you have any doubts?
Yes, I muted. Yes, no issue. Yeah.
Okay. So fouling factor is resistance of heat transfer, as I told you, and the thickness of scale, which means how much is the example. This 0.01 means what is the scale formation which will be on the copper tubes. So assuming this, the manufacturer will be already have considered the duration with respect to the resistance. So this is what the meaning of fouling factor. So in simple way, how much heat transfer resist flow per unit area per degree Celsius of temperature difference per watt of heat transfer. In simple terms, how meter square degree Celsius per watts. This is in simple terms you can understand about the fouling factor. And this is the operating parameters of an air cooled chiller 5444. Same. Here you don't have an water cooling tower basis, and only the ambient temperature you need to consider while selecting the chillers. Yeah. Okay. Coming back to Coming back to coefficient of performance. So this is an important parameter when you define a chiller. You might be hearing what is the COP of the chiller. So even in the tenders or in the consultant specifications, they will be specifically mentioning about the coefficient of performance. So what is COP? It's output by input. So the relation, okay, COP the energy efficiency can be mentioned in different parameters. One is the COP and one is kilowatt per ton. So per ton, how much kilowatt I need for a chiller? Okay, so in both ways, you can specify the chiller efficiency either through kilowatt and kilowatt per ton. There is one more term, EER also, that is mostly used in the European countries. So, so I did not talk about this. So COP is kilowatt per ton by kilowatt input. So for example, 3.516 is your kilowatt, which is 1 TR. How much is your COP is 3.3 COP. So higher the COP is always better, and lower kilowatt per ton in the chiller efficiency is always better. Okay. So what is the COP range? We have it in an air-cooled chiller and water-cooled chiller. COP at full load 2.8 to 3.2 based on different manufacturers at HRA conditions. So this HRA conditions I have already given you the inputs how it is, and the IPLV is 4.2 to 5.3. So this specifically what is IPLV and NPLV I will explain to you in the next slides. And this is a water-cooled chiller. This is the COP levels 5.8 to 7. As I told you before, water-cooled chiller has a highest energy efficiency compared to the air-cooled chillers. So you can look into that. As I told you, higher the COP is better the chiller efficiency. Okay. So going to the next to answer the question raised. So this is an important formula and thumb rule to calculate the cooling capacity. So TR is equal to GPM into delta T by 24. In this formula, you will have to keep in mind the 3 points. What are the points? In order to use this formula, in the above formula, we can input only 2 parameters, either TR, GPM, GPM, delta T, or delta T, TR. Only these combinations are possible. Okay. Cooling capacity is proportional to water flow rate. TR is proportional to GPM. Delta T is inversely proportional to water flow rate. Delta T and water flow are inversely proportional. Okay. So I have a quick example for this. Okay. Coming back to the delta T and district cooling. Okay. So in Middle East, you will see about something like district cooling and chiller operations. You have a cooling capacity of 100 tons. Here also I am having 100 ton. Chilled water inlet is 14.5. 4.5 is the outlet, which is having a delta T of 10. And chilled water inlet is 12.2 and 6.6. You have a delta T of 5.6. So what will be the water flow rate? Anyone can answer this question? Okay, fine. Since we have a limited time, I will just move on. Okay. So here is the formula I have already calculated. We have a TR and we have the delta T. So we just need to find out the GPM. So in a district cooling, always the thumb rule looks like 1.3 to 1.5 GPM per ton. And in a chiller operations, we have up to 2.4 GPM per ton. Say for example, in case, okay, you have 15.5 and 5.5 as a delta T. Still, the delta T remains same. This one remains same. Say you have a 9-degree delta T in some applications, so your GPM per ton gets reduced. Same here, 12.7 if you go. This is the GPM per ton. 5-degree delta T, you get 2.6 GPM per ton. To answer the question which was asked, the delta T and the water flow rate, how it has been designed is it is as per the designer or the consultant who designs the particular project. Based on the HAP load calculations, the cooling capacity is being arrived, and the designer will check whether they have a district cooling load or the chiller operations, how they can do it. So nowadays, most of them are going for the high delta T. The main reason behind this, compare these two water flow rates. You have the same cooling capacities, and why they are going most likely with the district cooling plant or this particular delta T is you have a lesser water flow going through the buildings, which means much lesser pumping flow, and the pumping load can be reduced. The pump sizes can be reduced. So that's why the high delta T is being most likely used in the industry to reduce the pumping energy. I hope it answered my your question, the person who asked in the group.
Yeah, Mr. Aldab, you asked me this question. Is that okay?
Okay, fine. We'll
continue.
We'll continue now. Okay.
Yeah, I have one
not
question
visible.
for
If
normal.
here after the
Hello. Can
test.
you be audible?
Yeah,
Hello.
you're audible. Please go ahead.
Naga, is audible?
Yes,
Yeah,
please,
you're audible. Please.
please continue.
Yeah. See, we are designing new project. For example, normally we select the chiller. Okay, well, we calculate the capacity of the chiller. Okay.
Okay.
But normally we forward to the manufacturer or specialist to select the delta T and capacity. So why cannot we cannot design the delta T? Normally delta T will come the less than 10 degree, correct? So I have to select from myself, yani, temperature.
No
delta
need.
T.
You're from consultant or you're the contractor?
Yeah, I'm consultant.
Yeah, you're the consultant. Okay, sir. See, if you see the comparison, as I told you before, when you go with high delta T, your water flow through the building is much lesser.
No, I'm not going the high delta T. Delta T will be the less than 10 degree. Okay. So my selection will be 8 degree. I will suggest no goal will be the higher side of the delta T. Okay. So select. I am selecting the T2 and T1. Which base I will select? I mean, normally we are getting the all.
Okay. See how to answer your question. Yeah. To answer your question, your chilled water. Okay. First, when you go for the chiller operations, you the operating range for the chillers is say like.
Manufacturer.
Sorry.
So from. Hello.
Sir, your voice is not audible. Hello. Sir, your voice is not audible.
Yeah, we couldn't hear you. Yes, please.
Hello.
Yeah.
Yeah, audible?
Now we can hear you. Yes, please.
Yeah, okay. Yeah. Okay. Continue.
Can you repeat the question, please?
Every time I have to. No, actually, I am designing for the 250 ton or 300 ton capacity of the chiller. Okay, I select the load, everything. Correct. So now I will use this manufacturer. Okay, they will give me the capacity, all data information from the manufacturer. Okay. So I have to select from myself. I mean delta T 5.4, 5.5 or 13.2, 13.3. Which base I will select? Any? This is a parameter.
Sir, this has to come from the consultant side based on the based on whether you have either a district cooling or the chiller operations, and based on the analysis, like when you have a normal application like a residential applications, if you go with a high delta T, okay, in general I'm telling, when you go with a high delta T, you
I'm
have
not
a very
loading a high delta T. I will delta T will be 10 degree. This is my sufficient capacity of delta T.
No problem.
So my concern is 5.5 or delta T 13.5. I can select which base I will select any. That's my concern. 5.2, 5.3. This is a range, you know. This information I will get from the we are getting from the manufacturer. So I have to from selection from which base I will select. This is my concern.
Okay, see, in order to achieve 24 degrees Celsius inside your room, okay, this chilled water temperature. Hello, yeah. In order to
set point temperature 24 degree, 23 to 24.
Even if it is 24 or 22 degrees, even if it's 24 or 22 degrees, the chilled water will be either 5 or 6 degrees Celsius or maximum 7 degrees set point. So your chilled water outlet will be remaining the constant, like, okay, 7 degree will be the set point. And based on the delta T for a chiller manufacturer, chiller manufacturers, the basic range of operation for the set point is from 5 to 15 degrees Celsius. So whether with that particular delta T, your RH is being completely absorbed, or it is particularly based on the complete indoor design actually. So from manufacturers, what are the inputs you have to give it to us is basically the delta T, whether it is 12 or 7 or what is the delta T. And then based on this, the manufacturer will design this. So manufacturer will not recommend to you like anything like you need to select for 10 degree delta T or 5 degree delta T. I hope it's clear, sir. Okay, we'll discuss in the later stage this particular topic. Okay, coming to IPLV and NPLV for any chiller for both water cooled and air cooled, this is the same formula: 0.01A, 0.42B, 0.4245C, and 0.12D. So what is A, B, C, D? So I have another Excel sheet which I can discuss upon. Okay, see, you have A, B, C, D, which you have seen in the formula. So what does IPLV means? Integrated part load value. Okay, this is defined by HRI. If you take a lifetime of the chiller, all the chillers will not always run in a 100% load what we selected for. So this will you have a much varying ambient conditions, and this will have a fluctuation on the internal load of the building. So based on this, the loading pattern of the chiller, loading pattern, they have segregated into 4 points: 100, 75, 50, and 25. And the ambient ranges 35, 27, 19, 13 degrees Celsius. These are degrees Celsius. And the weightages, they have given 1% for 100% loading, 42% for 75% loading, and 45% for 50% loading. And for 12%, it is 25% loading. So A, B, C, D are the COP levels from the manufacturer data. Like 100%, what is the COP you're getting? So 2.96. And so when you multiply both and sum it up, you will get an IPLV of 4.35. So this is how you calculate the IPLV. And what is NPLV is non-integrated part load, which is respect to your region and which respect to your building progress. Say, for example, this particular data, if I'm changing it to 46, and this particular COP levels, I'm changing it to 2.2, automatically the COP level gets changed here. And instead of 35, I'm getting them from the manufacturer, say 2.3. Automatically, this efficiency is being coming down. Always, okay. In considering the Middle East ambient, always the NPLV will be having a lesser data because the ambient levels are higher, like 46 degree and 35 degree, what we considered during the part load conditions. So this is the basic comparison of IPLV and NPLV. So this is a sample one, which this is as per the standard for a water cooled chiller at various condenser water entering temperature. This is for an NPLV sample, which I have given over here: 90 degree Fahrenheit, 77.5, 65, and 65. So this is all about NPLV and IPLV. This is also a key important factor when we select an air cooled chiller and a water cooled chillers, where the COP levels has to be COP and the IPLV has to be evaluated properly. So higher the COP, better. Always the higher. Okay, I'll explain to you the next stages. Okay, so we will go to a short summary what we have learned now. Okay, these are the important points which you will have to note it down when you are evaluating a chiller. So matching the required cooling capacity for the project requirement. And power consumption, is it including the compressors and condenser fans? COP, IPLV, and evaluating if the chiller can unload up to minimum load of the building. Say you have a 100-ton chiller and your minimum load is say 10%. At least minimum the 10 TR the chiller has to operate. So that's why the chiller minimum load has to be analyzed before selecting the particular cooling capacity, or in this case, the capacity of the chiller should be brought down further. and delta T is correct, and chilled water parameters are correct. Water pressure drop across the heat exchangers, because this will have an impact on pumping calculations, and dimensions of the chiller, whether it's fitting in your area, and noise level of the chiller if any acoustic treatment is required, because most of the buildings coming up here are the residential buildings. You may need to have an acoustic jacketing for the compressors and low noise on the for the fans. Okay, so what are the types of starters we have with the chillers, and how it has been related to the energy efficiency? We have a DOL starter, which is direct online, which is most likely used for a scroll chillers, and star delta starter, which is the conventional type, and soft starter, variable speed drive starters. So what are the difference between these starters? I will just quickly explain with the graph over here. So when you take a star delta starter, it starts with a star, and it goes to a delta with a high spike of inrush current. The starting current of the star delta compressors are always high. And when you compare with the solid state starter, yes, it will be further higher than the star delta starter, but this will have a smooth transition. This will not have any spikes, unlike like a star delta starter. Star delta starter, when you compare the star delta starter with the variable speed drive will have a smooth transition from starting from 0 and till the running load amps. So VFD, the life of the motor is more, and the energy efficiency is also more when you have a VFD chillers. So with the star delta starter, okay, there are some limitations. The number of starts and stops in a particular hour. Say you have power shutdown, and then again you have to start the compressor again, because since there's a spike coming up, there will be a timer to cool down the motor. Because of the high inrush, the motor gets heated up. So this can be avoided with solid state and VFDs, where you have much lower inrush current and number of start and stops can be done. So as I told you, with respect to the VFD, this is a conventional power consumption, and with respect to the VFD chillers, you can go very low, like 25%, up to 25% energy efficiency you can expect in a variable speed drive starters. So when you see a power consumption between non-VSD and a variable speed drive, the full load performance will be better for a constant speed drive chillers. Okay, and when you go down the part load conditions, the percentage of savings you get much better in a variable speed drive, either in water cooled or in the air cooled chillers. With respect to varying ambient conditions, you get a good benefit on the variable speed drive. So this is variable speed drive. In most of the projects nowadays, it's coming with a variable speed drives, considering the energy efficiency, life of the motor, and considering these conditions, variable speed drives are envisaged in most of the projects. Okay, so variable speed drive, we have to give more money. So what is the return on investments we are talking about? So I have considered a 300-ton chiller, air-cooled variable speed drive, and the conventional speed drive chillers. And as I explained to you before, 24 hours and 300 days the chillers are running. Your difference in savings you're getting annually on the power consumption, you're getting say $32,000, and the basic cost of the chiller, like this air-cooled chiller VFD is $157,000, and conventional chiller is $130,000. So you're paying $27,000 more. So this $27,000, how it can be recovered with an additional cost? Because one way you're getting savings on the power consumption, and one way you're investing on more. So this is a initial investment. So this will be, the return on investment will be less than a year when you go for a air-cooled chiller and a conventional speed. But before making a choice of variable speed drive and a conventional speed drive, you need to check the operating pattern of your building requirement, whether you have more part load conditions coming up in your buildings, and this is really going to be, as I told you, because the energy efficiency is bringing down when you have like lesser percentage of part load. So based on this, the call has to be taken. So I've just given a go in detail about water cooled chiller and an air cooled chiller operating cost, how it is being calculated, how much energy efficiency the water cooled chiller is. So this is a water cooled chiller, 300 ton I have taken, and this is annual energy kilowatt per ton, 0.5. Okay, this is only for the chillers. Okay, when you consider the plant room, what all you have in a water cooled chiller plant room? You have a chiller, you have a primary pump, you have a condenser pump, and the cooling tower. So considering 24 hours and 365 days, all the equipments are running, and you have like 24 multiplied by 7 and 365 days, you have 8760 hours. So the total kilowatt hour will be 1.44 million for a water cooled chiller. So how it is for an air cooled chiller? This is also close to a similar capacity. This is an annual energy efficiency of an air cooled chiller, 0.92. And this is also running the same comparison we have done. This is consuming like 2.38 million kilowatt hour. So when you compare the operating cost between these two, you're saving around $93,000 per year. Even though the water cooled chillers, you need a higher maintenance cost, still you detect some value here. Still the water cooled chiller efficiency is better. Okay, so understanding about the decarbonization, okay, in a nutshell, how we can tell about decarbonization is we have a lot of carbons being accumulated over the past generations in the atmosphere, which we'll have to remove it or we have to reduce it. So more number of renewable energies we are taking now actions, not only all the countries, they are taking measures to reduce the decarbonizations, to reduce the power consumptions, because there are multiple ways we can reduce the decarbonization is using an energy efficiency equipment, or choosing the right choice of the refrigerants, and reducing the transportation costs and transportations locally. So these are the things we are using to implement in the decarbonizations. And understanding about the global warming potential. So global warming potential is the measure of how much heat is being in a greenhouse gas traps in the atmosphere compared to the carbon over a specific period of time. So it tells how much powerful the gas is at global warming. So CO2 gas is the maximum proportion which has been available in the atmosphere. So the gas is taken as reference as 1. Say for an example, if another gas has GWP of 100, it means it traps 100 times more heat than the same amount of carbon dioxide over a same period of time. So some of the examples about global warming potentials on the refrigerants what we use, which is higher still. Now the refrigerants what we use with R410A and R32 are still having a global warming potential of higher. Nowadays we have much lower refrigerants like R1233ZT, which is HFOs, which has been coming up in the future, because even R134A also till 2040 only will be able to use. Even R410A also will get phased out actually. So how do you calculate the CO2 emissions? CO2 emissions is energy consumption multiplied by emission factor, kilogram of carbon dioxide per kilowatt hour. So what does emission factor? How much carbon dioxide is produced for unit of energy? So this particular unit of energy depends on the source, whether it's coal, gas, or solar. So each country has some emission factor being defined. For UAE, it is 0.5, as we are using mostly the natural gas as a medium for to generate the power. So carbon dioxide emission, say 10,000 kilowatt hour multiplied by 0.5, which is 5,000 kilograms of carbon dioxide, which has been emitted. So why we need to reduce the carbon dioxide, which is because of the climate change, because CO2 traps the heat in atmosphere, causing global warming and extreme weather. And we see like the natural disaster which is happening even in UAE also. The more rain was coming, melting of ice caps, rising in sea levels, and damage to the ecosystems are driven by high CO2 levels. And this is something which I want to talk about is the net zero energy buildings. In a nutshell, net zero energy buildings is balance between the amount of greenhouse gas emitted and produced and the amount is being removed from the atmosphere. So all the renewable energies, say for example, a building is consuming like 100 kilowatt hour. The same 100 kilowatt hour which has to be produced from the renewable energy resource, which has been given, so that it becomes balance, so that we are not giving any harm to the atmosphere by giving higher carbon dioxide. So the future will be moving towards net positive buildings, which is we will be generating more amount of renewable energies, which will be helping the environment to go better. So we come almost to the end. So what all we discussed, why it has been used for, what is the need to focus on the selection of equipments, different types of chillers, and what are the important parameters for selecting the chillers, COP, IPLV, NPLV. And we had seen about comparison of water cooled and air cooled chillers, and decarbonization and net zero buildings. Yeah. So now, thank you so much. Any questions are most welcome. Now we can have a question and answer session to discuss further.
Yes, Raghavan, there is a question raised from Mr. TIECONN. Yes, you can start.
Yes, please.
Hello.
Yes, please.
Hi, my name is Mohammad Bashir. I have one question about heat exchanger capacity. In my current project, we have the heat exchanger capacity is mentioned 445 ton.
Okay.
So it is this is a plate heat exchanger.
Okay. Okay.
So okay, this capacity for the plate heat exchanger is okay for with that capacity, because you mentioned there 150 ton, so I have confusion.
Okay. The 150 ton is being manufactured in the chiller is 150 tons. But
Okay.
the heat exchanger,
But
which
this
is being
district cooling project.
No, it's okay. That's what I'm telling. The plate heat exchanger technology for evaporator, because in a chiller you have multiple heat exchangers. You have an brace plate heat exchanger, shell and tube heat exchangers. So in a chiller, brace plate heat exchanger is utilized only for 150 ton. So when you go above this, the compactness of the heat exchanger will be much bigger size, because the shell and tube has we have the good capacities coming up with the shell and tube heat exchangers, because in brace plate heat exchangers you are using most of the stainless steel materials. So when you compare the cost between the brace plate and the copper and the aluminum and the heat exchangers, this is we have a. So I understood your question, because it's a standalone brace plate heat exchanger, right? What you're talking about, 400 ton for a district cooling.
Yes.
Yeah. So
Yes.
absolutely no problem. This is only for the chillers I'm talking about.
Okay, sir. Okay.
Yeah. Any other questions?
Yes, Raghavan, there is a question from Arifullah. I think, yeah. He has the conventional primary and secondary pumps.
Okay.
So he's telling, please explain whether only one set of pumps with the VFD is sufficient, and whether the chiller should have the VFD type of compressor also.
It is always when you have a variable water flow in a building, always it is recommended to have a variable speed drive pumps also. And okay, there is a big there are some concepts like individual pump is dedicated for individual chiller. That has been mostly beneficial. So I'm not an expert in pumps, but most likely this individual pumps dedicated for individual chiller, this is much better, rather than having multiple pumps for one working. Okay, that is completely that has to be completely analyzed based on the power consumption of the pump when it is operating in a part load, how it has been performed. We'll have to basically understand about from the pumps how it has been analyzed. So as a system, as a chiller, as a system, variable flow, yes, the chiller can take variable flow, and the compressor also variable speed drive. Yes, the energy efficiency is much better.
So he mentioned that he further added, Azizi projects are all are one set of pump set.
Okay, that's what I
So
told.
yeah,
That means the analysis between the part load of the pumps and the chiller efficiencies all will be calculated based on this.
yeah, when it comes to multiple pump selection, we have to consider other parameters also that we didn't highlight here anyway. So because we just focus only on the chillers, the in and out technical parameters. When it comes to pumps, it's a variable primary or secondary, whatever it is, that we didn't go further deep into that subject. Okay, that we will have a section again to decide what type of thing we can move for the pumps anyway. Yeah, so anything else?
Any other questions? Feel free. We can always discuss.
Yeah, we'll be more happy if we get more questions. So we can understand that you have got something from today's webinar. So please ask more questions.
Okay, let's understand from the team, from the people, how the webinar is. It too much fast, or you're not able to understand? Let us hear it from the team.
I have one question.
Yes, please.
Chiller testing for outside. So which base I will check? IPL well, 25%, 50%, 75, and 100%. Correct. So I want to
Yeah.
see my COP. Which base I will check? As per HRI, yes, Wi-Fi something. You
Your voice is
Hello.
breaking, I think. Ragun, can you hear properly?
No,
He's
I'm not getting the right informations.
Yeah, he's talking about IPLV, but there are some issue with your network.
For example, hello. You
Yes,
audible?
Yes,
For
okay, yeah.
example, I'm going for chiller testing for outside the country. Okay. Okay. So I want to see my selection of COP as per which base I will check 25 IPLV 25, 50 or 7500 or which base I will check.
Okay. Okay. You might have received. Okay. What has been? Okay. Two things. Okay. Two things to answer. What has been agreed from the manufacturer? Because
yeah.
I think there is a voice lag actually. So basically,
you
you need to understand.
You can
continue. You need to understand basically the what has been agreed with the manufacturer. Point number one. Second thing is, I believe you are buying AHRI or a Euro 1 certified chiller. So any one point of testing and verifying the data with what has been given, it's more than sufficient. Unless and until if it's an AHRI certified chiller or an Euro 1 certified chiller, then absolutely no problem. Hope it answered your questions. Okay, I'm picking some of the information about magnetic bearing chillers. Yes, this I missed during the presentation. So magnetic bearing chillers is it's an advanced technology where this has been there in the past. Only because of the cost consideration, this has been not been implemented in many of the projects. Magnetic bearing chillers will be the same parameters you will need to consider. Whatever only the compressor is changing from a screw compressor to a magnetic bearing chiller. Rest all remains the same actually. So a magnetic bearing, the one advantage is it has no oil in the unlike like a screw compressors. Magnetic bearing will be worked on a principle of levitation, magnetic levitation. You will have some sensors in the inside the compressor motor, where you will have like position sensors where your shaft will be like rotating without any friction. So your performance will be 10% higher than a conventional chiller, approximately. Any other questions?
Yeah, Raghavan, I will add one more question asked by Emil. what happens if we change the delta T range? For example, you told that we have the range from 5 to 15 for the chillers. So what if I change the range from 8 to 18? So he's asking still the delta T same. The delta T is 10 degree only, but instead of ranging from 5 and 15, what if we change from 8 to 18? So the delta T 10 degree same. So will it be affecting the 24 degree room temperature or not? So this is the question.
Okay, before that, you need to check the air handling capacity with respect to 8 degrees Celsius. Okay, where, in an air handling unit, like say you have 24 degrees Celsius and you're changing the set point from 7 to 8, there will not be much impact. You will not feel that particular impact on the temperature difference. So you can, if you want to increase the set point from 7 to 8, it's okay, no problem. You will not able to feel the difference between 7 degree chilled water and 8 degree chilled water. Yeah, only the thing is you will have to recheck on the air handling unit from the manufacturer. What is from changing from 7 to 8, what has been changing. Definitely there will be a duration in the cooling capacity when you have a higher chilled water going to the air handling units, because there will be a slight duration in the capacity as well. When you increase the temperature from 7 to 8. On the other hand, your cooling capacity on the chiller will be higher. As I told you, like as I explained in the pH chart, when you change from 7 to 8, the chiller capacity is increasing. On the other hand, the air handling unit, there will be a slight duration in the capacities.
Yes. So to add further,
still you will be able to meet the set point temperature, but it will take some more time. Yeah.
Yeah. So in the continuation of the same question, Aswak asked that what is the starting temperature of delta T? What is the lowest temperature we should fix for the delta T?
Okay, the chiller operating range in the evaporator side is from 5 degrees Celsius. Okay, this is the set point temperature which I am talking about, 5 degrees Celsius up to 15 degrees Celsius. You can operate the chillers. This is the set point temperatures, even for air cooled or water cooled. And some data center specific chillers can go up to 20 degrees Celsius, from 5 degree to 20 degrees Celsius. These are special chillers specifically for data centers.
So I hope this is clear. And moving further, that we have one more question. Please explain about the derating of chiller.
Okay. Okay.
Yeah.
This is a very good question. I need to dig around another presentation for this. Basically, okay, I will explain you with this chart.
If you have the information, it's fine. If you have prepared the chart, it's fine. If you don't have the chart to explain, then you can post in the group also. So
no issues. No
just
issues.
to confirm here. Yeah.
Okay. You're able to see the chart, right? Okay.
Yeah.
So
Right.
the refrigerant capacity is this actually in the bottom area. So when you try to reduce the temperature, when you tries to what is the duration factor is the question, right? Okay. Say you're selecting a chiller up to, like say this is your 35 degree range, 35 degrees Celsius, and you're derating the temperature up to 46 degrees Celsius, which means the compressor has to do more work and there will be a duration factor on the compressor. Okay, this is point number one. And with respect to evaporator side, this remains the same. Considering delivering only the chill water, only the compressor capacity is being changed. So how much is the rough percentage when you rate from 35 degrees Celsius to 46 degrees Celsius, considering the Middle East condition ambience? It will be around 15% duration you will have from 35 to 46 degrees Celsius. Hope it answered the question.
Yeah.
And let us talk about the duration factor with respect to the ambient conditions. And even when you increase 1 degree Celsius or reduce one in case of a water cooled chiller, when you reduce 1 degree inlet of a water cooled chiller, approximately 3% of power consumption, the improvement in the power consumption can be seen, and reduction of approximately 3% energy savings you will get when you try to reduce the condenser water temperature. And when you try to increase the water temperature from on the evaporator side, the additional capacity you will be getting on the chiller side. But this has to be evaluated properly with respect to the air side as well. Yeah. Yes, Nagaraj.
Yes, actually, I just want to add, if you see the ASHRAE 90.1, the from 2016 revision, I think chapter 6, I believe. So chilled water system with a design capacity exceeding 300 ton. I believe that minimum temperature difference must be 15 degree Fahrenheit or 8.3 degrees Celsius. So this is the revision happened from ASHRAE 90.1 to the 16
How much?
revision.
What is the degree of?
Yeah, minimum 15 degree
15.
Fahrenheit or 8.3 degrees Celsius if the chiller capacity, chilled water system capacity exceeding 300 ton. So so you have any view on this thing?
See, as I told you, when your delta T is more, like earlier conventional things, they were talking about 5 degree or 6 degree delta T. When your delta T is more, your pumping energy is less. That means your water flow rate is less. Water flow rate and delta T are inversely proportional. Okay. When you increase the delta T, your water flow is less.
Yes,
So
correct,
when you have a water flow, when you have a lower water flow in a building which is going to the building, your pumping energy is less. So there is a reason behind for giving these specification is like say imagine a 300 ton chiller. We were talking about so much millions of power consumption has been used when you operate a chiller. So even the pump also will be even if it's not going to majorly impact, but still the idea is to reduce the energy everywhere across the system. That is the major idea, because the current world what it is going is like we need to save energy to have a healthier environment.
Yes. So Raghavan, this one more question. If my room temperature is varying 24 to 22, then what will be my delta T?
Still your delta T remains the same, only the temperature on the, see this for a room you will be having a fan coil unit, correct? You will have a fan coil unit and increasing, when you change from set point from 24 to 22, you will require a lesser capacity maybe, and this will be achievable, but the thing is, okay, from 24 to 22 still it is achievable. Say you are designing because always the design will be based on like 23 plus or minus 1. Considering the diversity factor, the valve will be opening full and this can be achieved still. The delta T remains the same. Basically this only for this particular missions, the delta T will be slightly inversely proportional, so the delta T will be slightly higher, but this particular fan coil unit will be connected to a common header, so that delta T will not affect much even when you're varying the temperatures.
Yeah.
Hope I answered this question, or should I repeat again? Okay, what I was trying to tell is this will be most likely a fan coil unit which is having a smaller capacity of maximum say 5 ton. In a building of like say 300 ton or 400 ton, 5 ton, changing only the set temperature will not have an impact on the delta T. This is my answer.
Sharing is not visible. Screen sharing is not visible.
No,
Screen sharing is.
I have not shared anything. I am
No,
just
you're not sharing
replying to that.
screen, sorry. Just explaining.
Oh.
Yeah.
I'm just explaining things.
Okay, so there is a last question because of this time. We will have the last question now. Which one is best, AHRI or Eurovent for GCC?
There is a common. I have seen something in the past like AHRI and Eurovent. Both of them have the similar conditions available, but with respect to the chillers, what I've seen is HRI has more stringent things with respect to the fouling factors, because the Euro 1 standards, I have not seen any fouling factor has been mentioned in the selection of parameters. So with respect to the chillers, I would say like HRI, they have a higher hand on evaluating the performance.
total cooling load adum change agunda.
But in a nutshell, both are both HRI and Eurovent are a third party, which will be evaluating the performance of the units. Most likely, all the Americans or they go with the HRI specified, and the Europeans most likely with Eurovent. But as such, for a chillers, it is even some of the European manufacturers are still sticking to the HRI standards as well. So most of the manufacturers, it will be with the HRI. The big players, when you train your Carrier, Daikin, all are with the HRI certified.
So I hope the question sections are okay from all the participants. So this was a very detailed one, I believe, because you people asked most questions. So that made us very interesting to have more webinars in the coming days. Yes, we will. There is a question related to the pumps also. Yes, we are planning for a very detailed section for the pumps regarding the primary, secondary, all these things. So we will discuss very detailed in the pump section also. So now moving further, we are going to the question and answer section. So now I'll share the QR code, so you can screen and you will be directed to the question section. So please provide your answer in 1 minute. So these questions are very easy. We have taken from the basics only, and now it's time for the question and answer. I'll just open the QR code. Yeah, so here is the code. Please scan. And please answer within maximum in 1 minute. I will just share my screen. Sorry.
Yeah, your screen was not visible.
Yeah, that's fine. Yes. Everyone, please write your contact WhatsApp number so we can contact them in case you made the answer correctly. Okay, so please write it clearly.
Could you please share the link, because I cannot read the barcode through my phone.
Think, okay, we'll try.